So, hello. Let's talk about standard integrals. Let's consider the definition. Whenever a function, say f prime of x, is recognized as the derivative of a function f of x, then this is true. That is, if the derivative of f of x is equal to f prime of x, it implies that the integral or the antiderivative of f prime of x must be equal to f of x plus the constant k. And then we know that integration is a process that reverses differentiation, or is just the direct opposite of differentiation. So thus, any function whose derivative is known can be established as a standard integral. Now, let us put this into perspective. Putting this into perspective, let's talk about this integrating a function a multiplied by x plus b all to the power of n. Now, how can we integrate a function of this nature? Now, to understand this better, let us consider a function. Let's say we know that the function f of x is equal to, in bracket, 2x plus 3 all to the power of 4. As you can see, this is a composite function. In another video, we are going to learn how to differentiate a composite function. Now, in this case, we are talking about integration. How do we differentiate this function? Let's say I want to differentiate this function, f prime of x, which is the derivative of the function. This is equal to, first you have to integrate the function inside, that is 2x plus 3. The derivative of 2x plus 3 is 2. Now multiply by the exponent 4. All of this into 2x plus 3 all to the power of 4 minus 1, which is 3. So the derivative of the function f prime of x is equal to 8 into 2x plus 3 all to the power of 3. Now, what does it imply? It implies that if I know that the derivative of a given function is this 8 into 2x plus 3 all to the power of 3, then by the process of integration, we can establish that the function itself must be 2x plus 3 all to the power of 4. That is, by integrating this function, 2x plus, by integrating the derivative, that is 8 into 2x plus 3 all to the power of 3 with respect to x, this should give us this function, 2x plus 3 all to the power of 4 plus the constant of integration k. Now, how is that possible? You see here that the coefficient is 8. Here, the coefficient 8 is gone. And the exponent here is 3. Here, the exponent has been increased by 1. Now, it becomes 4. So, this simply means that if we multiply this by 1 over 8, then here, this should be 1. So, in other words, it means that if I know that the derivative of a given function, 2x plus 3 all to the power of 3 with respect to x, is this is possible that the given function must be 1 over 8 into 2x plus 3 all to the power of 4 plus the constant k. Now, this with this being said, now we can establish a general definition. Let's establish a general. Now, let's say the integral of a function ax plus b all to the power of n with respect to x. This must be equal to 1 over, here when you differentiate ax plus b, you get a multiplied by the new exponent, because when integrating, you always have to increase the power by 1. So now this becomes n plus 1. All of this into ax plus b all to the power of n plus 1, that is the new power, plus the constant k. So that should be the general definition. So for ax plus b all to the power of n, so the integral of ax plus b all to the power of n with respect to x dx is equal to 1 over a into the new power, which is n plus 1, all of this times ax plus b all to the power of n plus 1 plus k. Now, let's take an example. Integrate with respect to x. Let's consider the integral of, let's say, 4x minus 2 all to the power of 3 with respect to x. Now, integrating this simply means the value of a is 4, so this is 1 over 4 multiplied by the new power. So we have to increase the power by 1, that is 3 plus 1. All of this into 4x minus 2 all to the power of 3 plus 1 plus the constant k. So this is going to be 1 over 4 times 4. All of this into 4x minus 2 all to the power of 4 plus the constant k. Now it becomes 1 over 16 into 4x minus 2 all to the power of 4 plus the constant k. That is how we integrate easily. Let's take another example. Let's take another example, number 2. Let's say we want to find the integral of 2x plus 7 all to the power of 5 with respect to x. This is equal to 1 over, the value of a should be 2, into the new power, which is 5 plus 1. All of these times 2x plus 7 all to the power of 5 plus 1 plus the constant k. So this should give us 1 over 2 times 6 all into 2x plus 7 all to the power of 6 plus the constant k. So the final answer is 1 over 12 all into 2x plus 7 all to the power of 6 plus the constant k.